Welcome back with another episode of TryHackMe.com. This is Ahinazi, and we are doing Intro to Infrastructure as a Code, which is part of the Infrastructure as a Code module, and we are following up the DevSecOps learning path. So we already done from task 1 to task 5 in last two videos, and in this video we'll be able to complete from task 6 to task 8. So let's get into it. So it's about virtualization and IaC, infrastructure as a code. Okay, so let's see what we have here. When discussing infrastructure as a code, virtualization is a fundamental concept. Virtualization technologies, when used in conjunction with IaC, allow for some powerful and efficient infrastructure management. That is very correct. When everything is going okay, then everything is okay with infrastructure as a code. While some of these concepts have been touched on in the introduction to containerization room, this task will review virtualization and its relationship with infrastructure as a code. Sure, virtualization levels. When we talk about virtualization levels, we are essentially talking about what is being virtualized. Here we will briefly review the difference between hypervisor level virtualization and container level virtualization. I touched about a little bit in the containerization module to provide context of upcoming concepts. Hypervisor virtualization VMware enables multiple virtual machines to run on a single physical server. Imagine a physical server in a data center using a hypervisor. This server resources, CPU, storage, and RAM can be divided and dedicated to separate virtual machines within this server. These machines will virtualize everything from operating system, which can be a different OS than installed on the host, meaning the multiple OSs can be installed on a single server. However, deploying a virtual machine at this level can take some time. Containerization platform example Docker is virtualization at an operating system level, meaning the same operating system same operating system kernel is used to run multiple containers. Virtualizing at this level makes this container incredibly lightweight, allowing for rapid deployment and scaling. So what we learned here, we learned that the containerization is virtualization on the operating system level, which makes it very, very light. But on the VM side, it is virtualization on the hardware level, not the hardware level, the hypervisor level, where separate virtual machines are there in the server, and each virtual machine will have its own operating system. Okay, so that means each virtual machine will be running its own operating system. That means there will be a lot of overhead, which Docker containers don't have, because they will virtualize the operating system which is already there on the host. Okay, and that's why it is very lightweight as well. Okay, let's see the graphic here. We have the hardware, we have hypervisor, we have host, OS, hypervisor, and then Fedora, Windows, Debian, and what is this? Ubuntu have their own guest OS inside. Okay, but here this is hardware. This is kind of showing that it is modern. Containerization, we have host, we have Docker engine, and then our Ubuntu containers are running share OS kernel. Okay, so in virtualization they have their own OS. They don't share any kernel or anything. In Docker containerization, they share the OS kernel here. All right, let's move forward. Use of virtualization in IaC. Let's consider how virtualization is used in IaC across 6 areas: scalability, resource isolation, testing, snapshots, rollbacks, templates, multi-tenancy, and probability. Sure. Let's see each of them. Scalability. IaC uses virtualization to meet demands, higher or lower levels of demand. If there is a sudden increase in demand, scaling policies can be defined in your code to specify when this would be required, and you need more servers. Virtual machines can be created to handle this increased load. I mean, it really depends. If you're using Kubernetes, it will take care of everything for you. or if you are using just Docker container engine, then you may need to apply some policies. And if you are going with the virtual machines, uh, in that case, for example, there could be a distribution for the VMware, which will allow you to create more virtual machines on the hardware to handle the increased load set here. Okay, so it's really depends. Resource isolation, virtualization enabled resource isolation between different VMs containers. Using IaC, you can define what components get how much of the available resources. This means if one component start getting hammered, consuming all of its allocated CPU, memory, bandwidth, it won't affect the performance of the other components. Yes, we touched this point before in the containerization that um, we will define that what are the resource limitation for each container or the pod, and the pod or the container cannot go beyond these resources. Okay, so what happens is if we allow them to go beyond these resources, then it will impact the overall stability of the whole ecosystem. Okay, so that is where the resource isolation will come into the place. Testing, snapshots, rollbacks. The virtualization of OS, software configuration dependency make it easy to package them, and using infrastructure as a code, deploy them in another identical environment for testing or deployment or development. The consistency this provides, combined with the ability to take snapshots of the VM containers at specific points in time, so rollback can be done if a deployment goes wrong, streamlines development and testing processes. Yes, even if you know about the VMware, you have some options to take a snapshot. Basically, it will take the snapshot of the currently running processes in the RAM, and you can go back to that state if you want to. Okay, same is true for the containers as well. Templates. When using virtualization, you can create a template, a blueprint for VMs, containers. IaC is infrastructure as a code, can use these templates to provision new instances. These templates cut manual provisioning and configuration time down while ensuring consistency across instances. For example, you created your development environment, you need to have a same on staging. You will just create a template and use it to create the staging, UAT, pre-production, or production environments. Okay, multi-tenancy. Virtualization can support multi-tenancy, meaning multiple customer tenants can be hosted on the same physical server whilst having their resources isolated. This removes the need of dedicated server, single tenant environment, although sometimes they are required. Using IaC means the resources for multiple tenants can be managed using the same underlying infrastructure. So tenant mean, for example, two different companies resources needs to be hosted on your infrastructure. So what you will do, so or maybe two different domains there you need to host, what will you do actually? So this is called the multi-tenancy here. In a nutshell, it's a broader concept by the way. Okay, portability. Virtualization makes it easier to move infrastructure between cloud provider or data centers. We know that from our previous tasks that some of tools that we'll use are cloud agnostic. That means they can work across cloud, either on Azure, AWS, or Google. Okay. So if we are using these kind of tools to create the configuration templates, then the portability will be there. Okay, we'll achieve portability. So portability will do what? Portability will enable virtualization, make it easier to move infrastructure between cloud providers or data centers. Okay, or even create a DR or whatnot. Having this portability as described can streamline critical business processes like disaster recovery, but also allows the flexibility for hybrid cloud organization to recreate environment regardless of their cloud service provider. Okay, awesome. Virtualization technology plus IaC. Next, we will discuss some virtualization technologies used in conjunction with IaC to unlock its power, focusing on Kubernetes. We discuss a little bit about Kubernetes. Kubernetes, also referred to as KIDES, is a containerization orchestration software, meaning once an application and its dependency have been containerized, Kubernetes can be used to automate its deployment, scaling, and management. Using Kubernetes require a Kubernetes cluster, in other words, an infrastructure made up of a master node and one or many worker nodes. We discussed all of this in Intro to Kubernetes room. Just check it out in the playlist on the YouTube. Where the containerized application run, infrastructure as a core tool can provision the underlying infrastructure needs for this Kubernetes cluster and automate the setup of required Kubernetes components. Infrastructure as a code can also define scaling policies for a Kubernetes cluster, automating the scaling process, allowing pod nodes to be added or decreased based on the resource usage. The infrastructure provisioning, configuration, and automation capability of IaC, combined with the ability to orchestrate lightweight, rapid, deployable container, make for a very powerful setup and is ubiquitous in the world of cloud computing. So what we learned from here, so if you are using containerization technology, so in order to manage the containerized deployment and automate its deployment, scaling, and management, you need to use something called Kubernetes. It's a containerization orchestration software which will help you manage the scaling and all other things of your system. Okay. Instead of doing everything manually, Kubernetes will take care of everything for you, mostly everything for you. Consider a practical example from the world of DevOps. Say a DevOps engineer is planning to deploy a new web application from scratch, and their tech stack include both Terraform and Kubernetes. So we learned that Terraform is a cloud agnostic and is a declarative agentless tool, and which can be used to provision the infrastructure. Okay. If you don't remember, we can just go and I think check the tool set here. No, maybe in the last one. Just a moment. I'm just want to show you this one. We have Terraform. It is declarative. We have no agent, and it uses for infrastructure provisioning. Terraform and Ansible are used in a composition. Okay, one is for configuration management, and the other is for infrastructure provisioning. I hope this is clear now. Let's move on to where we were here. So this is the practical example we're talking about. So we have both Terraform and Kubernetes. They are combined. They can combine these tools and use Terraform to automate the creation of new Kubernetes cluster. I mean, the infrastructure and provisioning and all these things. Once this cluster has been deployed, and other resources that might be needed, like Nginx web servers or load balancer and all these things. We know that the load, see, now they use the load balancer term here instead of service in the context of Kubernetes. This is just a simple stripped back example of a task that would even be possible by just using kubectl or other CLI based tools to manage Kubernetes or KIDES cluster and resources. However, using an IaC technology like Terraform boosts many benefits when you start to consider DevOps at the scale of a larger company, where these tools allow you to define Kubernetes deployment, services, config, maps, etc. As Terraform modules, which are repeatable across different projects, clients, and environments. We have also discussed how Terraform is a declarative tool, ensuring that the state of the Kubernetes cluster matches the desired state, making infrastructure management an easier task. Yeah, that is very true. Terraform is also aware of dependencies, meaning if a resource X is dependent on resource Y and resource Y fails to deploy, Terraform won't attempt the creation of resource X. Another way in which Terraform can save time is by reducing the need for DevOps engineer to shift through deployment errors, working out the point of failure. Again, both of these tools are powerful, but when used together, their true power and utility in the DevOps space are unlocked. That is very true. Kubernetes is just one example of how virtualization technologies and IaC can work hand in hand and are nearly essential to each other, at least to get the most out of the respective tools. Some other examples include Vagrant, used by developer to spin up and manage VMs or containers for local development and testing. IaC can make this a consistent process, and OpenStack, an open source cloud computing platform where you can create your own cloud environments, where IaC can also be used to automate the provisioning and management of cloud resources. So we have OpenStack and we have OpenShift as well. So both of them are competitor of each other. You also have the VMware and I think Nutanix as well. This is just an overview of virtualization to emphasis to use within ISC. But if you want to learn more, we have plenty of rooms that go in depth on this topic, like virtualization, containerization, and introduction to container. Introduction to containerization we already covered. Let's see what we have in virtualization and containerization. Maybe we'll cover it in a later module once we finish with our current DevOps path. Okay, so I will just move it here so we know. So these are all the rooms that we need to cover once we finish our DevOps learning path. Okay, let's move forward. CyberMine is deploying the latest machine model E1000. This model requires virtualization at an operating system level to allow for lightweight and rapid deployment behind the scenes. What level of virtualization would be needed for this? What level of virtualization? We need OS level virtualization. So we have container level, hypervisor level virtualization, and we have container level. I think let's put the container. If that does not accept it, then we'll post OS level. All right. So let's do that. Okay. So let's see. We have containerization and we have hypervisor. Relation. What level of virtualization would be needed for this? Okay, just a moment. So we have visualization. We are essentially talking about we have different visualization, hypervisor and container visualization, context, hypervisor visualization, VMware, and so this is kernel level, containerization level. Okay. So it's visualization at operating system level. Containerization is a platform is visualization at the operating system level. So containerization, maybe we were putting spelling wrong, maybe. This should be it. Yay, okay, so our streak level is also increased. CyberMine's E100 model is still very popular for all your extermination needs. This model requires multiple OS to run on a single machine. Which level of visualization would be needed for this? So we have hypervisor level. Hypervisor. Awesome. We are good. The new E1000 model has a feature that allows it to pass through physical objects. Wild, okay. This new feature, however, is very resource intensive, which use of IaC will ensure that this resource consumption won't affect the performance of machines' other component. Which use of IaC? So these are use of IaC. Resource isolation is the way to go. All right, we are good. Due to the resource consumption of this new feature, it requires rapid scaling of resources, which container orchestration software can be used to automate this process. Kubernetes. Here. Awesome. So we are 20 minutes into the video, so let's cover the next task, which is 7. On-premises IaC versus cloud-based IaC. All right. Wow. Okay, infrastructure as a code has two use cases: on-premises IaC, cloud-based IaC. Going forward, this module will go in depth and give practical example of both of these. Let's first establish the key difference between the two. Here's the outline. Key difference between on-premises IaC and cloud-based IaC across 5 categories: location, tech, resources, scalability, and cost. Comparison. Location. On-premises, as the name implies, if your infrastructure is on-premises, then the code written will configure servers, network devices, storage software located on your premises. This can mean physical infrastructure in a in a premises owned by an organization or rented in a data center. Cloud-based. This means provisioning and configuring infrastructure resources in a cloud environment using cloud resources. This is done using a cloud service provider, CSP, such as AWS, Microsoft Azure, GCP. All right, we are good on that. Tech. On-premises, typically when working with an on-premises infrastructure, IaC tools like Ansible, Chef, Puppet would be used. Even Terraform. Although other can be configured to do so to manage and provision infrastructure on physical servers or virtual machines in an on-premises data center. In a cloud base, there are many tools available to provision and manage cloud infrastructure designed to leverage the elastic nature of the cloud computing, with some cloud service provider having their own IaC tool service. Some example of tools that can be used for cloud-based IaC or Terraform. AWS CloudFormation, Azure Resource Manager. At least they managed to mention something about Azure here. Azure Resource Manager, ARM templates, and Google Cloud Deployment Manager here. All right, resources. So this was the tech. On-premises, when using on-premises IaC, this is the resources. We will likely be dealing with physical hardware, which comes with the caveats of hardware capability, physical upkeep, and limited physical resources. This will mean setting up and configuring those physical resources, physical servers, storage devices, network equipment. On-premises IaC may be used by companies who rely on their on-premises infrastructure due to legacy systems, require assistance in the efficient management of this infrastructure. So that means on-premises, there will be physical resources, physical hardware that we need to manage, and that means somebody needs to be there in order to manage it. Okay, and there is a maintenance cost associated with the on-premises. Cloud-based, in the cloud, you interact with virtual resources provided by the cloud service provider, AWS, GCP, Azure, you name it. These resources can be provisioned, managed by cloud-based IaC tools. The underlying infrastructure is handled by CSP and not the user. Cloud-based IaC would be perfect for companies that offer video streaming services. Due to the nature of this service, it can lead to a fluctuating demand on computing resources, which can peak. Cloud-based IaC makes it easy to gain access to additional cloud-based virtual machines or storage depending on resource consumption to ensure consistent performance during these peaks. So on premises, you already know your capability, your limitation. On cloud, basically you can acquire new resources as per your demand. Okay, you can decrease or increase the resources, and the billing will be as per the resources that you are using. But on premises, I mean, billing is as per the capacity that you have, right? So there is a capacity payment and there is a actual resource users payment. Okay, so both of them are different in this context. Scalability. Okay, on-premises scalability, scaling resources using on-premises IaC can be slow, cumbersome process. This can involve manual physical changes and procurement. This is very true because scalability is such a slow process. Consideration is required and hardware limitation must be enough to handle peak load. This can prove challenging in situation where an on-premises infrastructure start receiving increased traffic. Think enrollment or exam season at a university or college. So it's like, for example, if your underlying infrastructure is designed to handle, for example, 100,000 users, and now you are getting like 120, 150,000 users. That means your physical hardware is not enough to handle all of the increased load. So in this context, you need to procure new physical servers and all these things. Okay, and this process itself will take time to manage and do because of the budget constraint and all other constraints. Those are and those are inherited in on-premises environment. Whereas in the cloud, I mean, it is elastic. So let's see what we have in cloud. Cloud-based, due to the cloud's elastic nature, scaling resources is far more flexible than on-premises. Cloud-based IaC tools can define scaling policies, so resources can be scaled up or down based on the demand, resource consumption, leveraging auto-scaling features. Yeah, this ensures that only the resources needed are paid for. Yeah, and cloud-based IaC can streamline the processes of scaling infrastructure to meet the demands during peak seasons. Because it is cloud-based environment, and that means you have uh, room to wiggle in. Okay, uh, depending on the resource requirement. I mean, you can either shrink or scale your infrastructure as you need. Okay, and you pay for only resources that you consume. So this is a plus point on the cloud environment. Basically, the ability to scale is much higher and speedy on the cloud environment as compared to on-premises environment. I hope this is clear now. Then this ensures only the resources needed are paid for. Yes. Cloud-based IaC can streamline the process of scaling infrastructure to meet demands during peak seasons. Yes. Imagine an infrastructure that supports an online game. This infrastructure would see increased traffic when the game releases a new update or an event is underway. That is very true. Cost is a main factor here. On-premises. On-premises infrastructure expenses mean having to pay for physical hardware or lease a server from a third-party data center depending on the use case. This also comes with cost of physical upkeep, fault repairs, part replacement, operational costs, expenses involved in upcoming upgrading the infrastructure, and on-premises infrastructure and the use of on-prem IaC does not boost any cost benefit per se. If choosing on-premises, it would likely be due to a combination of other factors rather than cost. Okay. So on-premises, I mean, there is a cost associated with it, and also there is a cost associated with the cloud-based as well. I mean, you cannot say that on-premises will cost you more in a long run as compared to the cloud-based. I will explain why this is not true. When using cloud-based IaC, you will deal with infrastructure that cloud service provider bill for on a pay-as-you-go basis. This means You only need to pay for what you use, which can be made more cost effective by efficient use of autoscaling. Cloud-based IaC tools are an ideal and cost-effective solution for scenarios where infrastructure needs to be automatically scaled up and down on demand. For example, if an online retailer is expected an increase in traffic over Black Friday or White Friday or whatever Friday weekend or over the holiday period, they may want to scale up their resources but not have to pay for those resources when traffic returns to an average rate. This is very true. When comparing cloud-based infrastructure as code with on-premises infrastructure as code, it primarily comes down to the location of the infrastructure and what tools are used in their management and provisioning. Cloud-based IaC uses virtual elastic resources, which are charged on a pay-as-you-go basis and provided by CSP, whereas on-premises IaC deals with the physical hardware. So, okay, even though you have, for example, unlimited resources you consider on a cloud-based environment, it doesn't help you with the billing. Why? Because once you have unlimited resources, or if you consider that there are unlimited resources in the cloud-based environment, you tend to create a lot more resources than whatever you need. Okay. On premises, you already have constraint about the limitations and what you can do on premises, right? And there is a cost also associated with those changes that you will do. So usually on premises, the workloads are optimized to use every inch of the performance that we can get out of the physical servers. On the cloud base, you usually over provision. Okay, so that means because in your mind you already know that, okay, we can always provision a new VM for this workload or that workload. Okay, so this may increase the overall cost of running the business on the cloud-based environment. So it really depends upon how optimized your workloads are, and if they are optimized for having cost effectiveness. Okay, so cost effectiveness could be either on premises or maybe in the cloud-based environment as well. So I have seen some companies which were paying less on premises for same workloads, but they are paying more on the cloud-based environment because basically once you have this mindset that it is unlimited, you can create as many servers as you want, as many workloads as you want, and you will just pay as you go. You tend to over provision a lot of resources there. So all of this needs to be considered while choosing any of these here. Okay, let's continue. Benefits. Let's examine how the above mentioned differences translate into benefits depending on specific use cases. Here are some of the benefits of each to give you an idea of when you might use on-premises IaC and cloud-based IaC. Okay, awesome. On-premises IaC, the main advantage of on-premises infrastructure as a code is that it allows complete control. This complete control is sometimes required due to regulation, security, and compliance requirement. This is very true. This is common in bigger banking corporation or businesses that deal with customer sensitive or government data. These regulations can call for data sovereignty. That means the data should not leave your premises, meaning the data has to be stored and processed within the country. Yes, this is a requirement all over now since the innovation of the cloud computing. Wise cloud provider offer a specialized government cloud environment like Azure Cloud. They have a US government-based data center which are isolated from other data centers. For some of these cases, e.g., US Cloud in AWS, these offerings are only available in certain regions. For regions like Africa, there is no dedicated government cloud, meaning no on-premises infrastructure as a code would need to be used to adhere to strict security compliance requirements. Cloud-based IaC, it has many advantages for fast-paced growing businesses. The scalability allows infrastructure to be rapidly scaled up or down to meet the fluctuating demand without the constraint of physical on-premises infrastructure. Cloud-based infrastructure also allows infrastructure to be deployed globally across different regions, reducing user latency, which can be essential for businesses that needs to provide a service to customer worldwide with little to no latency, like online gaming. And this is very true. With cloud providers billing on a pay-as-you-go basis, this can mean that the companies can pay only for the infrastructure that they need or use, meaning investment does not need to be made into physical hardware and the maintenance of that hardware. That is very true. So one main point of the cloud computing is that, for example, uh, you launch your initial gaming setup or service, for example, in Middle East only, right? So you will be using the cloud provider which are there in the Middle East. And what if you want to also open up a new uh, area or a new region, for example, Europe? So what you will do? So in order, you cannot use uh, the cloud providers that are there or the data center that are there in the Middle East, because the latency will be too high, right? The customer will not be happy. So what you will do, you will use the data centers that are there in the Europe side. So the latency to open the website and everything will be less region wise. So this is how the cloud itself will empower you to basically launch a global solution, uh, which will give the optimal performance as per the region. Okay, let's move on. Cloud based resources are provisioned, configured in a cloud environment. Who handles the underlying infrastructure? Cloud based resources are provisioned, configured in a cloud environment. Who handles the underlying infrastructure? Cloud, of course. Uh, I think cloud service provider. Cloud service provider. Yeah, okay. What category does on-premise infrastructure struggle with due to hardware limitation when facing increased traffic? What category does on-premise infrastructure struggle with? Scalability, I think. Scalability. Scalability, I'm not sure. Yeah, okay, awesome. We guessed it and it was the same that we needed to do. Okay, so last task is final push. Let's see what we need to do. We'll view the site itself. Time to fire. The technology required to send Sergeant Miles Cheese back to 1984 is being held in the lab complex. All that's left now is to capture it and retrieve the tech. There's only one issue. It's located in a heavily fortified exterminator base, and the resistance does not have the resources to take them on. Lucky for the resistance, so one piece of the technology they do have their hands on is their infrastructure at a click. Infrastructure as code, and they have infrastructure as a click weapon system. This allows a resistant fighter to deploy a weapon infrastructure requiring a network and server component so the weapons can communicate with each other to take on the machine army. After all, the weapons can be reprovisioned and resistance fighter cannot simply define how many weapons you want using provision points and upgrade those weapons using configure points to defeat the incoming machine. Just don't let the machines take over your server or it's game over. Okay, so we need to, I think, play this game. So let's see. Level 1, developing your skills and instructions. Please press S or click the light bulb for status and options. Right click on the battlefield to provision weapons. Right click on a deployed weapon to configure it. Okay. You have been assigned 2 points. Allocate them wisely. So I have 1 point here and 1 point here. Allow a greater number of weapons. Allows powerful upgrades and weapons. Okay. Each infrastructure has its own perks. Full control of infrastructure, you can place your weapons anywhere. Provisioning will be 500% faster. Destroyed weapons will respawn faster. I think let's go with cloud. Before you are ready to capture the lab complex, you need to get the grip with your infrastructure at a click plus configuration at the click tools. The resistance has spent time making test dummies for you to test your skills against. Uh, Thank them for blowing them too. Smithrians at E soldier. Okay, so we'll provision something. Uh, these different weapons simply represent the different needs of an infrastructure. For example, low levels of combat area. Okay. So can we remaining provisioning points is 1. What about this? These are different weapons simply represent the different need of infrastructure. For example, high levels of global traffic. So can we, increase it? Okay. So we have land weapons only. I have land weapon here. Lie. Okay, we are provisioning. So what happens now? Enemy is coming. Provisioning is I'll get 6 points. Let's go with 4 and 2. Let me go with here. Let's see. Let's go with. We have 2 for configuration and 2 for this one. Click the right button to start option and right click on the battlefield to provision weapons. Okay. So we are on level 2. Alright, so in level 2, you have been assigned 6 points. Allocate them wisely. We already done so. Save. So I will do 1 here as well. Remaining provisioning. Okay, so let me do 2 here. Save. Initiate. Apply. Alright. Apply. What happens here? Okay, these are coming from here. You can see we have 4 soldiers. Okay, congratulations, you moved to the next level. How many levels we have, man? Producing a victory, level 3. If you want to provision the infra, you use the previous level. Please click apply. Press the S key to first. Let me see what I have. We have 10 now. So I have. Let me go with 2 here and 8 here at least. Okay. But how many weapons I have? Okay, we have 8 weapons here. So let me go with 2 and 4 here. At least 3 here. Okay. So we are good. Let's move on and apply. Enemies are coming from both of these. All right, okay. Oh no. You have failed to defend the server. All right. Let me try again. We are on third level. We'll provision here. Next on premises. We'll provision 4 here. Now, for example, 3 here. And what about 3? I cannot go beyond that. So I need at least 3 here. Okay, let's go with 4. Because we can have just 2 here. Okay, let's go with 2 here and 3 here. All right. Bye. So enemies are coming. Can I change? Oh no. Come on, come on. Finish him, finish him. No. So guys, we are playing this game, but we are not able to win this. I don't know how to do this. Allows powerful upgrades to the weapon. Okay, let's go with 6 and 4 this time. For control infrastructure, you can place your weapons anywhere. I think let's go with the on-premises provision. So I have remaining provision. I can do 2 here and 2 here. All right. So select the on-premise infrastructure. You can place the weapon on the highlighted positions. Okay. Come on. Finish, him. Finish. 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 Finish him. Finish him. Come on. Finish him. Finish him. Finish him. Come on. Finish him. Finish him. Finish him. Come on. Finish him. Come on. Yeah, so finally we are able to do it. This is our flag. Awesome, congratulations guys, we have finally done it. So thank you for joining me on this journey. If you like this video, please give it a thumbs up. If you haven't subscribed, please subscribe. If you have any suggestion, please put it in down below, and I will see you in the next video. Thank you. Bye bye.